Thank you, Caspar. Thank you very much. So as the title suggests, I would like to invite you to take a look with me at the way we usually build CI/CD pipelines. And I guess the premise of the session is quite straightforward, really, because so over the past few years, I've noticed what I believe is a, let's say, common problem when it comes to building CI/CD pipelines. And so what I'm going to do is I'm going to start out by explaining or describing the problem. Then I will give you a few reasons why, in my opinion, it is in fact a problem. And then we'll be looking at a solution together. Right. And the idea is we're going to be doing about 50-50 in me talking with slides, and the other 50% will be me doing some coding on stage to keep it a bit interactive for you and not just me droning on. Right, and before we get started, I actually have some good news for you. As Caspar pointed out, this is the last session before lunch, and so the good news is there's a good chance you're going to be on time for lunch. Two reasons. Thank you very much. Thank you very much. Reason for this is, as it happens, I work for a company called Deutsche Bahn in Germany. That's the national railroad operator in Germany. Maybe if you've been, you would know. And my mission today is I'm trying to improve our reputation a bit, because if you've ever been, you would know that, how do I put this? Yeah, exactly. We have a bit of a reputation that on occasion our trains are known to be running a little bit late. Right. And I'm looking to improve on that. So yeah. Let's get started. Now with about the problem. When it comes to CI/CD pipelines, one of the most common things when you or your colleagues need to work on them is that you're going to have to, for example, add a new stage, because most of the time in the real world there has been a pipeline in place before. So, for example, let's assume this is a testing conference that your job is to add a new stage that runs, let's say, Selenium tests on your web application. We learned a lot about Selenium the other day, right? And so the way usually people go about doing that is, they add a new stage and then they have a rough idea of what they want to do. Usually it'll be something like, copy some files, run some shell command, whatever, run some script. And then most of the time it won't work immediately. And then what you do is you take a look at the error message and you try to think of why it doesn't work immediately. And then you try something else and you do that a couple of times until eventually it works. And this way of operating, this method has a name. It's called trial and error, basically, right? And in my experience, at the huge majority of times, this is exactly the way people go about building CI/CD pipelines. And that's the problem, in my opinion, right? And there's a couple of reasons that this is, in fact, the problem. Reason number one, it's very, very slow going because turnover time is so long, right? Usually, the worst case scenario is always when you have a stage where, where the stage you're trying to implement depends on previous stages, because then every time you do the try thing, you have to wait for the previous pipeline stages to run through until you can give your a new try. And it'll usually be a couple of minutes. You need to wait every time. You can't really do anything in between. So it's very slow. Reason number two, maybe it's just me, but I find this very annoying to work like this, because you're always just going from one error to the next until at some point, hopefully, it works. And the third, and maybe the biggest reason is, which kind of annoys me the most, that this is not actually how we would usually go about doing software development when we were actually writing normal, regular application code. Because the way we do that, hopefully, you all do it that way, is we come up with a plan at first, right? We think of how should our application behave in certain circumstances. We come up with a plan, we think of all the scenarios that might happen, and then we have a plan with how we want to implement our code so that our plan is going to work out. And usually, the way we would do that is we would start by writing tests, because then we can start covering all the cases, the scenarios we thought of, and ensure that our application does exactly what we want it to do and how we intend it to work. So that's really the most annoying part to me, really. And the fourth, and maybe even equally important reason is, it's actually very dangerous to go about and do it this way, because if, like me, or us, let's say us, you have a CI/CD pipeline that actually does continuous deployment as well, where you automatically deploy your app, your service, whatever, to production. There's no manual step in between. And if, in fact, your pipeline is not well tested, then the worst thing that can happen to you and happen to us is that you start deploying stuff you don't actually want to deploy into production, and then if, worst case, your app's going to break and your users are going to be very unhappy. And in the case of Deutsche Bahn, this usually results that next day it's all over the newspapers and everyone's like, nothing works at Deutsche Bahn, so on, so on. So yeah, that's really the big reason, in my opinion, you shouldn't go about building pipelines that way. And now the big question obviously is, what's a better way of doing that? The answer is spoiled in the title of my presentation, really, because it's simple. I think the bottom line is it takes, let's say, a shift in inner attitude, in that we have a tendency to make to distinguish between regular application code and other stuff, such as code used for your pipeline. And really, what I'm trying to say with this session, if you're already starting to, zone out, thinking about lunch, then the big message you should take away from this, and giving it early, is you should really treat your pipeline code with the same standard, you should hold it to the same quality gates that you would with your regular code. And the consequence of this is very simple, because we know that when it comes to regular software development, writing code, the way of doing it, that basically nowadays everyone can agree is state of the art, is you do it in a test-driven way, right? I don't have to explain to everyone, because this is a testing conference, what test-driven means, right? You start with a test, then it should fail, then you start implementing your code so that it passes the test, and then if need, you do a refactoring run. And you cycle through this continuously. And we know all about why this is a good way of doing software development, for the reasons we're all aware of. Pays off often in the midterm, sometimes even in the short term. For certain, in the long run, it makes your software and your code more flexible, because you have the this nice warm feeling of regression, that you know that if you change anything in your code, you can be certain that it didn't break anything else, because you have all the tests you've written previously, and you know that you didn't break anything, right? And so the key message here is that if you're doing CI/CD pipelines, the way you should go about it is do it test-driven, and really treat it the same way you would regular code. That's what I'm trying to tell you with this session. I could close it up right now. It's a bit early though. So maybe for those of you who are not thinking about lunch already, you are getting a bit curious about how can you actually do test-driven development for a pipeline. Because test-driven usually means we're talking about unit testing. And in the past, before I knew about all this, I was the same way, and I didn't actually know that there was a way for unit testing pipelines, right? And so the answer is obviously yes, it can be done. And for the next part, we're going to be looking at how it can actually be done. And the idea is, what we're going to do is I am going to build a CI/CD pipeline from scratch, like starting from zero, and I'm going to do it in a test-driven way. And the way we are going to do it is I'm going to do the coding, and you just need to sit back and relax. So don't worry, it's not like an exercise or anything. But you have to spot out you have to watch out if I make any mistakes. Right. So for this part, this is the critical part of my presentation, where I have to change from PowerPoint to my IDE. Okay, that went smoothly. Very good. Don't worry, I can hear it. Everyone complaining it's too small. Give me a second. Okay, great. Right, so what we're going to do is, basically we have a bunch of pipeline engines we could choose from. There's, plenty. There's GitHub Actions, there's GitLab CI, there's Bamboo. What I'm going to do is I have to obviously choose one for this session. And what I did was I went for Jenkins in this case. Maybe some of you have heard of Jenkins before. At least it used to be a popular CI/CD tool. I think now it's a bit on the decline, but there's a good reason I'm using this one. We'll get to that shortly. Give you a quick rundown of what we need. So I'm having a Java project. It's Java 11. I know this is a bit outdated right now. Last night at the hotel, I considered bumping this to 17, but then I decided against it because sometimes you open Pandora's box and then you never get any sleep. Then what else do we need? So we're going to be using JUnit 5 for our unit tests. I think most of you, or at least plenty of you, should be familiar with that. Then we have Groovy in version 3. And then we have really the heart of what this is all going to be about. There's a testing library called Jenkins Pipeline Unit, and this is really the key thing you need to do this. What it does basically is it gives you sort of a mock Jenkins, right? What it does is it executes the pipeline code you write against a portion of the Jenkins code that would run your pipeline, and it gives you the power to, for example, mock certain behaviors, right? And that's really all this is about. It's not an advertisement or anything. I'm not related to the library. I'm not getting paid for this or anything. I'm just a happy user I want to share with you. Right, and now, so to get started, what I'm going to do is I am going to start with a very empty pipeline script. It's very easy, even for those of you who are not familiar with Groovy. Trust me, it's very intuitive, and it's not at all hard to read. So what I'm going to do is I'm going to start out with an empty pipeline script. I'm going to call it Jenkins file Groovy. Right. So far, is anyone lost, or does anyone have any objections? No? No one? Yeah? What about it? Oh, it's just, the Groovy thing is just because it helps with the IDE, with the highlighting and the code and stuff, but that's not what I'm talking about. So it was actually a trick question, because just 5 minutes ago, I said I was going to do it in a test-driven way. Test-driven means? Right, yeah. So what I should have done really is I should have first written a failing test, shouldn't I? Everyone looking a bit shocked, yeah, but this is a testing conference, isn't it? Like, well, let's just put it this way. It's a good thing you decided to attend this conference, right? Okay, so I'm not going to go ahead and start with my pipeline. I'm going to go ahead and start with a failing unit test. And this may require a bit more explanation. So what we have here is just a very basic JUnit 5 unit test, really. We have our class, and we extend it from a class called declarative pipeline test. This is given by the pipeline library. And all we have to do is we have to call the super setup method, and then we can get started. Now, as you will see, this library provides us with a few helpful tools we can use for writing our tests. And the first thing I want to do is I will write a unit test, and we will want our pipeline to succeed. That's the most basic, simple pipeline you can really think of. So I'm going to call it pipeline should succeed. And then there's two things we have to do. The first one is we have to actually make our pipeline script run. And the second one is we will need an assertion, you all know that from basic unit test, that says that the result should be success. Right? And the way we do that is we get a method called runScript from the parent class. And this one takes one argument, and it's the name of the pipeline script we want to use. And that's one I used earlier, Jenkins file Groovy. And then for the second trick, we need to write an assertion. And as you can see from the autocomplete, there's a bunch of ones you can use, and it's the top one I want right now because we want our pipeline job to have status success. Right. Now, hopefully, this is the second critical part of doing live stuff. This should fail. We'll see. I will run this test, and hopefully this one should fail because it's trying to run a file that doesn't exist. Yeah, and as you can see, it's complaining because it says resource exception, cannot open file, Jenkins file, groovy. Okay, that is expected because we haven't actually added a pipeline file yet. So let's go about doing that. TDD cycle means second step is making the failing test pass. So this is where we actually start with our pipeline. And there's a bit of boilerplate code. For those of you not familiar with Jenkins pipelines, I'm sorry, but it's not very difficult either. So it's basically you say, so this is a pipeline, ignore agent none, it's not important right now, and then you define a bunch of stages. Right? In the real world, the first stage would be, I don't know, do a git clone. Second stage would be do, I don't know, build my software. Then, I don't know, run integration tests, unit tests, Selenium tests, whatever. And at the very bottom, I don't know, deploy to some test stage and later deploy to production. And the minimal pipeline I can think of is one with just one stage. Let's call it my stage because I'm very creative like that. And I'm going to just make it say, hello, Nordic testing days. Right. I think this is for those of you familiar with Jenkins, I think we can agree that this is the most basic pipeline you can write. That it can't be any more minimal. Right. And so what I'm going to do is I'm going to rerun our unit tests. And as you can see, now it's green. That's great. And we can even see that it says it executed on a mock agent with a label none. And it also prints the result. So it's sort of like as if you would execute the pipeline against the real Jenkins, just that it's a mock Jenkins. Right. Now, this is obviously very basic. And so the next thing I'm going to do is I'm going to adapt the stage and do the most basic thing you can do. What I'm going to do is I'm going to build our service, our application. And since I'm a Java guy, what I'm going to do is I'm going to do a Maven build, okay? Right, so, and then we have two cases really that can happen. The first one is our Maven build succeeds, the happy path. And then again, we want our pipeline to succeed. And the second one is that the Maven build fails for some reason, and then what we want is for our pipeline to fail. Otherwise, it would be bad. Right, so let's rename this and call it given. Again, I'm starting with a test, right? You can relax, there's not going to be another trick question. Given Maven build succeeds, then pipeline should succeed. And what I'm going to need for this is to do our Maven build. Usually you go about it is you run a shell command, which is basically Maven clean. I learned at a different conference, you don't do Maven clean install, you should do Maven clean verify. So that's what we're going to do. And we're going to have to mock the behavior of the shell and control the return value of the shell command, really. And then by extending from the parent class, we get a field called helper. And this one has a method to mock all kinds of stuff. Like this goes on, it's a long list. And what we're going to mock is a shell command. And it takes 3 arguments. The first one is the actual command we want to mock. That's Maven clean verify. The second one, you can write something on standard out. We don't really need that. And the third one is, it's the actual return value. And the way shell works, a 0 return status always indicates success, and a non-zero value always indicates failure. So now, for the not so happy case, I'm going to do something you shouldn't try at home. I'm going to copy this method. I'm going to call it given Maven build fails, then pipeline should fail as well, right? And we are going to make this exit value, I don't know, 42, something non-zero. and we will need to assert that the job status is not success, but failure in this case. Right. Now, let's run this test, and hopefully one of these should pass and one of these shouldn't. Yay, okay. So the first one passed because we did mock the shell command, but we're not executing it yet, so it's still green. And the second one says, oh, I expected failure, but I did in fact get success. Right, so now again, test-driven means we need to adapt our pipeline in such a way that these test cases are both going to succeed. And there's just one way of going about it. We need to somehow invoke the Maven command. So I'm going to rename this to Maven build. And what I'm going to do is, I am going to execute a shell command. And then this one takes 2 arguments. The first one is the actual shell command. This was Maven clean verify. And the second one is called return status. And what this does is it makes it so running this shell directive actually returns the return value of the shell command. Right, and now if result is anything other than 0, then we want our pipeline to fail. And the way you do that, this is again a bit of a Jenkins specific thing, is you mark the current build result as failure. You can actually, it's balled here. This is how Jenkins treats failure. And the second one is I'm going to make the pipeline exit right after this stage and say, oh, I don't know, Maven build failed. Right, and hopefully when we run this, both of our tests should succeed again. Yay, okay, happy. Right. Now, what we've done is we've gone through, 2 or maybe 3 cycles of TDD, and this is basically the idea of how you can, from the very bottom up, start building your pipeline incrementally. Now, everyone's going to say, oh, this guy on stage, he only showed the very easy cases, but I'm on a clock here, it's only 25 minutes, so I'm very sorry. There's a lot more I could show you, but unfortunately it's very difficult to fit more into 25 minutes. Also, Kaspar, I get 5 minutes on top, right? Because the guys before me, they were a bit, they stretched it a little bit, so. Okay, right, so let's get back. Just kidding. I'm basically done with what I wanted to show you. Right, so let's get back to it. So wrapping up, this is basically just what I wished to show you. I think the key takeaway, I mentioned that earlier, so in case you forgot, just a quick reminder. Treat pipeline code the same way you would regular code. You can and should write your pipelines in a test-driven way, and this will make your pipelines and your pipeline code in particular way more robust and flexible, and hopefully after leaving Nordic testing days, none of you will still be using trial and error. Right, and that's basically it. That's the recap before I leave you to your lunch. And I think there's not much more for me to say, except thank you for traveling with Deutsche Bahn today. It's been great fun. And I wish you a lot of fun with the remaining conference. Thank you very much. Thanks. Do we have time for questions? We do, right? This is pretty much on time.
Well, you actually have a good 5 minutes more left if you want to carry on. So, but there's so many questions there. Let's get to it.
There we go. Yeah, hi. But in this, like you go on and you can see, so each change, you can see whether or not it actually worked. But to me, it looks like the problem is still there, that if you have a lot of stages and like at some point you get to, yeah, but it will still depend on the previous stage, then it's going to take a long cycle to, like, here you built everything and it took like 5-10 seconds, but then when that build cycle and going through each next step will take 5 minutes, then you still have a slow feedback loop. So how do you, I mean, you will know it was the last change that's messed it up, but if we go, okay, I can fix it, oh, I can't fix it, it will still be a very slow process, won't it?
I think the main difference is, since we're doing unit tests, those are very quick to execute, right? Like they take milliseconds to run. And in this way, I think you're going to be a lot quicker. Maybe what you're thinking about is when you have stages which take a long while to run. For example, you're polling a server or something. But that's not something where you would actually do the real polling. This is a unit test after all, right? You would mock the result of the script. What you might be thinking of is actually doing integration testing for your pipeline. That's a different thing though, and that's something you can't do with what I've shown here. So maybe if you're saying, an integration test is more meaningful, it tells you more about whether what you did will actually work. That's right, you have a good point. But I think that's a limitation of what you can do with unit testing, actually.
Yeah, we got one more. Keep them coming, okay?
Hi, Lukas. Thanks for the presentation and the demo. Very brave of you, so well done. The obvious question now is, are there other mock frameworks supporting, for example, GitHub Actions? Do you know anything that could be of help to people not using Jenkins?
Yeah, it's the most common question to this sort of thing I'm doing. And it's the reason I did go for Jenkins. I'm not aware of any, to be honest. I did some research beforehand, and I'm not aware of any other pipeline engine where you can do this kind of stuff. I think one of the big limitations is that with, for example, GitHub Actions or GitLab pipelines, they're all based on YAML, and YAML isn't real code. So in a way, it's harder to unit test it. I think there would be ways around it, and in my opinion, it would be very desirable to have that for other pipeline engines. But as far as I'm aware, there's nothing else yet. So yeah, in my opinion, this is a good reason to go for Jenkins. I know I'm a bit old school like that, and it's not very en vogue anymore. But yeah, I'm not aware of any others. Sorry.
Hi, Lukas. Thank you. This was really informative, and I took a lot of stuff to take back home.
Thanks.
In my experience working with Jenkins files and whatnot, the most frustrating thing is that usually there's always stuff that it's got to be trial and error. Like, I got to send it to the Jenkins. And I need to commit it and then send it and just try it out to see the result of what I just put in place. Have you found in your experience by approaching this from a TDD perspective that you end up doing less of that, or the problem is still there?
In my opinion, it gets less. Of course, there are some limitations to stuff you can't really unit test. You're talking about the specific of Jenkins. This goes to the second question I prepared. There is a lot of stuff you can cover with the Jenkins specifics, but it does get tricky, for example, when you get to Jenkins plugins, because those are very specific, and obviously this library, it's impossible for any testing library to support all plugins there are. So in my opinion, that might be a limitation you run into, but for most of the general purpose Jenkins stuff, in my opinion, it does in fact help in reducing what you described. So yeah, it's obviously not a catch-all solution for all your problems, but it does make a great difference in my opinion.
Thank you.
All right, more hands.
I think that's it.
No.
Oh, sorry.
Okay, from my perspective, I'm working with Azure pipelines. Yeah, so sadly, I tried to Google for the last 5 minutes the library.
Yeah.
Do it. So
it didn't come up with anything.
No, unit testing is unit testing. So how you run your tests in the units? Yeah. But the question is more about, don't you think this is a part of the problem of the education of people about the pipeline building? Because most of people, for example, in Azure, will use pre-built blocks that they don't really know what they're doing. They find the tutorial online, and that is the information is very poorly given to us, and there is no coding schools for that.
True. Yeah, I think, yeah, I agree. You're right. So I guess, what do we take away from that? You know, you can't shake your fist at the air and say, okay, that's a bad thing. You can go about and start, you know, explaining it and sharing it with others, like I'm doing right now. And if you like it, hopefully you'll spread it, you know, where you work, and this way we can improve. But yeah, I agree. I know what else to say.
There's one more.
Yeah, thanks for the presentation. Usually I develop using the rerun function in Jenkins. So you can just like modify and take it stage by stage. But this looks quite useful. My question is, I use a lot of plugins.
Yeah.
And there, I think it doesn't work for that, right?
That's what I said earlier to Joao's question. I think this would likely be a limitation. I know of some very popular Jenkins plugins that are supported by the testing library, but obviously if you take more specific, obscure ones, you're going to run into limitations. But this should not hinder you, because the mission then, in my opinion, is you should go about and start adding support for the plugins to the library itself. It's open source, it's on GitHub, so if it's important to you, that's what you should do, in my opinion. But
or make the pipelines more stupid.
Yeah,
Only
I guess
use
so.
shell or
yeah,
whatnot.
obviously. Yeah. Actually, that's one of the lessons, you know, why people get so annoyed with Jenkins, is that they're saying, you know, there's this huge number of plugins in the ecosystem, and they are very different quality, and the most basic common denominator we can all agree on is shell scripts, so maybe it'll end up with that. Yeah, I agree.
Okay, I think we can squeeze out a few more there. Well, looks like we're done, and Lukas, you're one brave man, I have to say.
Thank you. Thank you.